Hi and welcome to Pre-Calc 30 with Miss Verity. Today we're going to be looking at 6.3 sum and difference identities. So on your screen there is a bunch of different sum and difference identities. We've got the ones for cosine, the ones for sine, and the ones for tangent. So depending on if you have an alpha plus a beta, that would depend on what your look is for your identity. So example 1, rewrite each of the following as a single trigonometric function of an angle. So we've got cos of 110 times cos of 80 subtract sine of 110 sine of 80. So first thing, this first value is going to be our alpha. The next value is going to be our beta. Notice we still have an alpha and a beta. And if you take a look at your pink sheet, there's some specific patterns. We've got cos with a cos, sine with a sine, and then we've got subtraction. So if we have our coses and our sines together, well, that gives us a cosine identity. And if it's subtraction in the middle, then it's our a sum identity. So this identity, it would be cos of alpha plus beta. Well, our alpha is 110 degrees and our beta is 80 degrees. So if we were to write it as a single trigonometric function, this would be cos of 190 degrees. If we wanted from there, we could figure out the actual value of that. And if we typed cos of 190 into our calculator, we would get negative 0.9848. Okay, so our next one, we've got an alpha, we've got a beta. In this case, we've got our sines and our cosines together, so it's a cosine and a sine, and we've got addition. Well, sines and cosines, if those are the ones that are kind of together like this, that is a sine identity. And if we've got addition in the middle, that is also a sum identity. So we've got our sine of alpha plus beta. And in this case, our alpha is 5 theta. So 5 theta, and our beta is 3 theta, should probably make that look better, which together gives us sine of 8 theta. The next one we're going to look at, we've got tangent of, we'll call that our alpha. So 50 is our alpha, 20 is going to be our beta. And in this case, we've got a subtraction in our numerator. Well, subtraction in our numerator is going to be a difference identity. So this is tangent of alpha subtract beta. So tangent, our alpha was 50, our beta was 20, those are degrees. And so this gives us tangent of 30 degrees. If we wanted to sort of solve this, figure out what this is, we can go to our special triangles. So this one is 1, 2, root of 3. We've got our 30 down here, 30, 60. Well, if we're at 30 degrees, our tangent is opposite over adjacent. So that is 1 over root of 3. Again, we don't like radicals in our denominator. So we're going to rationalize it and get root of 3 over 3. We are in quadrant 1, so it is positive. So example 2, find the exact value of the following. So with these, we kind of want to think of our special triangle values. So we've got 30, 60, 45, and then we've got our quadrantal angles, so things like 0, 90, 180, 270. And I guess 360 as well. So using those values, we want to figure out that two that add or subtract to give us 105. Well, 105 to me, I would say would be 60 and 45. So 60 plus 45 together, that gives us our 105. So this would be sine of 60 plus 45, and using our, those are degrees, using our sum and difference identities, so we've got our sine ones, it is addition, so 60 being our alpha, 45 being our beta. So our addition one would be sine of our alpha times cosine of our beta plus cosine of our alpha times sine of our beta. Again, you can use many different variations. Just because I chose 60 and 45, there's other ones that would work. You just have to have only 2 values. It can't be 3 or 4, 1, whatever. So now, using our special triangles. We've got 1, 1, root of 2. This is our 45. 1, 2, root of 3. This is 30 and 60. We are all in quadrant 1, so everything is positive. While sine of 60 is root of 3 over 2. So sine of 60 is root of 3 over 2 times cosine of 45, which is root of 2 over 2, plus cosine of 60, which is 1/2, and sine of 45 is root of 2 over 2. So this gives us root of 6 over 4 plus root of 2 over 4, which, because remember, when we add radicals, they have to have the same radicand. They're not the same. So this would just be root of 6 plus root of 2 over 4. Our next one is tangent of 15. I'm just going to do that one below. So this is B tangent of 15 degrees. Well, 15, for me, I would probably choose 45 and 30. So this would be tangent of 45, subtract 30. Again, we've got our alpha, we've got our beta. If we look at our sum and difference identities, we are using subtraction. So this one is tangent of our alpha, subtract the tangent of our beta, all over 1 plus tangent of our alpha times the tangent of our beta. So again, remember our special triangles. 1, 2, root of 3, that's our 30, 60 triangle. We've got 1, 1, root of 2, and this is our 45 degree triangle. So tangent of 45 is 1. Subtract tangent of 30 degrees. So tangent, remember, is opposite over adjacent. So this would be root of 3 over 3, because we'd get 1 over root of 3, which we would rationalize. So that's root of 3 over 3, all over 1 plus tangent of 45 is 1. Tangent of 30 is root of 3 over 3. What I might do here is I would multiply my numerator by 3 and my denominator by 3. That gets rid of our gross stacked fractions. So 1 times 3 is 3, subtract this would just be root of 3, because those would reduce to be 1, over 3 plus, again, those are going to reduce to be 1. This gives us a root of 3 in the bottom. We don't like radicals in the bottom, so we are going to use our conjugate. So multiply by 3, subtract root of 3 times 3, subtract root of 3. And as we multiply it out, so 9. So first, outside, subtract 3 root of 3. Inside, subtract 3 root of 3. Plus root of 3 times 3, or root of 3 times root of 3 is 3. All over our denominator, which when we multiply by our conjugate gives us our sort of difference of squares look. So 9 subtract 3. To keep simplifying, 9 plus 3 is 12. Subtract negative 3. Subtract negative 3 is negative 6 root of 3, all over 6. Here, because we've got common terms across every single term, we can reduce. We're going to divide each one by 6, so we end up with 2 subtract root of 3, technically over 1, but we don't need the over 1. So there's our answer. So example 3, a fourth quadrant angle. So fourth quadrant angle. A is a fourth quadrant angle, and tangent of A is negative 12 over 5. B is a second quadrant angle, and a sine is 3 over 5. Find the exact value of sine of alpha plus beta. So things we want to do here. Well, I would probably split it first into terms of, this is A plus B. So we're going to have sine of A times cos of B plus sine of B cos of A. So things we might want to look at as well. So if we're going to talk in terms of angle A, so we said that angle A is a fourth quadrant angle. That means our y is going to be negative. So we've got our x, our y, our r. If we're given tangent, we've got sir, kick, sir, ticks. So in this case, our y, this was equal to negative 12 over 5. This is our y. This is our x. So our y is negative 12. Our x is 5. If we need to find our sine and our cos of that value, we're going to need an r. So to figure out our r, that's our Pythagorean theorem. So x squared plus y squared is equal to r squared. So 5 squared plus negative 12 squared is equal to r squared. We've got 25 plus 144 is equal to our r squared. 25 plus 144 is 169. And when we take the square root, we get 13. That's equal to our r. We are also going to need to find our angle B. So angle B was in quadrant 2, meaning we're going to have a negative x. So same thing, we were given our sine of B was 3 over 5. And in this case, remember, so sine is our y over our r. So x, y, r. Our r is 5, our y is 3, and we need to figure out what our x is. So x squared plus y squared is equal to r squared. Our x, we don't know, is equal to our r squared. This will be subtract 9. In this case, our x squared is equal to 16. When we take the square root, remember we get plus or minus 4, but we know that because we are in quadrant 2, we need the negative version. So our x is negative 4. Well, using those values, we can figure out what we need. So sine of A is going to be our y over our r. So our y over our r is going to be, our y is negative 12 over 13. Our cos of B, cos is x over r. So our x is negative 4 over our r, which is 5. Plus sine of B, well, sine of B is going to be y over r, so 3 over 5. Oops. Sine of B, yeah, sine of B, 3 over 5. And cos of A, cos is going to be x over r, so 5 over 13. From here, we can simplify. So positive 48 over 65 plus 15 over 65. Oops. We've got our common denominators. That's awesome. When we add those together, we get 63 over 65. And if I'm looking for an exact value, which we are, fractions are our exact values. This question, we do the exact same way. We'd still find, we have our x's and our y's. We would plug that into our formula where we've got our, so this was a subtraction. So it would be tangent of A subtract tangent of B over 1 plus tangent of A times tangent of B. We have our x, y's, and our r's. Tangent is y over x. We would take those values, we put it in, we'd simplify. In our last example, prove the following identity. So sine of alpha plus beta plus sine of alpha subtract beta is equal to 2 sine alpha cosine beta. Again, I would probably take the more complex side personally. So this would be, let's take our sine of alpha plus beta. So sine of alpha, So using our identity on this one, sine of alpha times cos of beta plus cos of alpha sine of beta plus our difference identity. So we're going to have sine of alpha cos of beta subtract cos of alpha sine of beta. Well, looking at these, we've got sine of alpha, sine of beta is the same, or sorry, sine of alpha, cos of beta, sine of alpha, cos of beta. We've got adding cos alpha, sine beta, and subtracting. So when we reduce those, we are left with sine alpha, cos beta plus sine alpha, cos beta, which is 2 sine alpha, cos beta.